Today, we're going to examine 3 types of refractometers. First, we'll look at a traditional handheld refractometer that operates with temperature correction. Next, we'll explore the Rudolph handheld refractometer and finally Rudolph's benchtop refractometer, both of which function with temperature control. Handheld refractometers have been available for a very long time. They work well in certain applications, but there are some widely known limitations. The J27 from Rudolph changes that paradigm and brings benchtop performance everywhere you need to measure. The first sample we will test and compare is sweetened iced tea. Measuring materials like iced tea are a very typical use of a handheld refractometer. Chemically, they are mostly sugar and water, with a small amount of other material to give taste. Measuring sugar solutions to around 0.1 Brix is one of the most common application for a handheld refractometer. For this application, all 3 instruments perform exactly how they should. For the next sample, we will remain in the food category and analyze a liquid that is not primarily sugar and water. For this test, we will be using olive oil. Olive oil has a very different temperature coefficient than sugar water. In this example, the traditional refractometer that uses temperature correction fails and gives an incorrect reading. Both the temperature-controlled J27 and bench model perform the same because the sample is physically brought to the reference temperature, so an accurate reading can be taken. We now will test calibration fluid. Measuring a sample is a good starting point, and for many smaller users, upgrading from no measurement device to having one is a significant step forward. However, the next crucial step is ensuring that the measurement device is functioning correctly, which involves considerations like ISO standards and calibration. Let's take a closer look at what happens when we measure a calibration reference fluid. The calibration reference fluid is not just sugar and water. If it were, things would be much simpler. However, sugar water is not a good reference material because it is not stable over time. Chemically, it slowly inverts, and biologically, it's prone to contamination as bugs love to consume it. Because these calibration standards are not made of sugar water, they need to be measured at a specific temperature. Fluid manufacturers and standards organizations are aware of this, which is why they indicate the required temperature on the bottle. If the instrument used is not temperature controlled, the standard becomes useless. Finally, we will test cinnamon oil. Traditional bench refractometers have operated within the refractive index range of 1.3 to 1.7. This range has been the standard for over 100 years, dating back to the first Abbey refractometers. To keep costs low, handheld refractometers use simplified optics and function within only a portion of that range. Like a bench refractometer, the Rudolph J27 operates over the traditional Abbey range. In contrast, a traditional handheld refractometer does not cover this full range and often fails with many samples. With Rudolph's temperature-controlled handheld refractometer, you can continue taking accurate measurements even during a power loss. Unlike desktop models, its portability ensures your work stays uninterrupted, no matter the circumstances. Rudolph's handheld refractometer makes it simple to transfer your measurement reports directly to your desktop computer via Bluetooth. With just a few taps, your data is seamlessly sent and ready for analysis, eliminating the need for cumbersome cables or manual data entry. Enjoy the convenience of quick wireless data transfer, streamlining your workflow and keeping your measurements organized and accessible. Some other features on the J27 handheld refractometer include unlimited onboard concentration scales. Internal data storage holds up to 3,000 measurements. Laboratory 4 decimal place accuracy, while fully portable. Bright backlit 7-inch touchscreen. Ergonomic design that only weighs 3.6 pounds. Electronic Peltier heating and cooling to control sample temperature to 20 or 25 degrees Celsius. Lithium-ion battery provides 4 to 8 hours use. Rudolph's new handheld refractometer is equipped with a barcode reader. This option is not available on the traditional handheld refractometer or the benchtop refractometer. Rudolph brings decades of leadership with high accuracy, benchtop refractometers to handheld instrumentation. With the experience and innovation gained from over 2 decades of leadership in refractometer design and manufacturing, Rudolph introduces the new benchmark for handheld refractometers. The J27 refractometer is entirely untethered, yet refuses to accept the compromises in performance and accuracy of typical handheld instruments. Now you can measure everything anywhere with laboratory-level accuracy.